I'm going to spend the next few minutes giving you 3 or 4 practice problems identifying the direction of the magnetic force on a wire that carries a current. As I mentioned in a previous video, I'll keep using green for the magnetic field, I'll use blue for the current carrying wire, and I'll use red for the force, just to try to keep things consistent. After a while, I'm going to stop drawing the wire and stop labeling the magnetic field here. I'll just use the capital letter B vector because for some reason that's what we always use for magnetic fields. I'm also going to stop drawing the north and south. You just have to imagine that the field lines are still pointing from north to south. So in this example, we have a current that is pointing to the right, from left to right, from plus to minus. We have a magnetic field that points up towards the top of the page, and so the right-hand rule gives us this, a force that points out of the page. So if you were to switch on the current for this wire, you would observe that the wire moves upwards in this direction. It's a very strange effect. In this next example, I kept the magnetic field pointing in the same direction that it was in the first example, but I've switched the direction of the current, so this time the current points to the left. Again, using the right-hand rule, we use thumb for the current, that points left. We use finger for magnetic field, that points up. And so in this case, we would find that the wire experiences a force into the page. In this example, the wire carries current upwards, the magnetic field points down. You'll find that you can't really do the right-hand rule with this, and what that tells you is that you don't get a force in this case. This is kind of a strange thing. Wires don't always get a force from a magnet, even if they are carrying a current. They have to be carrying current in such a way that they have a magnetic field that interacts with this magnetic field in the right way to give it a force. In this next example, I've drawn the wire with a current that points into the page, so thumb points down this time. The magnetic field points up, so the finger points towards the top of the page, and that gives a magnetic force that points to the right. Hopefully soon you'll start to get the hang of this. This time the wire carries current up, the magnetic field points to the right, so the force on the wire would be upwards. Notice in all these examples, every single time the force is pointing at a right angle to the current, and it's also pointing at a right angle to the magnetic field. In this next example, the magnetic field points into the page, which is why I've drawn it with a bunch of X's. The current points up. Using the right-hand rule, we get a current for the thumb, fingers for the field. That means that the force is to the left. In this final example, the current points to the right, the magnetic field points out of the page, and that gives you a force that points down. Notice that this is a type of problem that you're likely to see on the final exam, some sort of arrangement where you've got a current and you've got a magnetic field and you're asked to find the force on the wire.